So this is the 2023 Battlebot cage testing, University of Tennessee. The first test that was done is the robot was allowed to ram the cage just to make sure that the panels would hold. See, they're able to back up and get as much steam as they possibly can for the ram. There were some initial concerns about the safety of the cage and how much we would be able to sustain in terms of impact. Okay, now that we've been able to do that first test, the second test is to just do a kind of a half-power weapons test on the steel itself. This is 20 gauge carbon steel, and so the weapon was brought up to somewhere around half power and allowed to ease into it. There was some sparks flying, and it actually did penetrate all the way through the steel, but it failed in a way that was safe. There wasn't pieces of steel that were shot all over the place, which is what the concern was. So now we allowed them to go ahead and go to full speed, ramming speed, and so they can. This is now fully penetrating through the steel. Kind of fish mouth sit about an inch deep with a direct hit when the weapon is able to get all the way up to full speed and come at it from a ramming. So the weapon is at full speed and the robot is at full speed. Okay, so while the panel definitely failed and would need to be replaced, it did contain all of the hits, even the sustained direct hits. Okay, for this next test, we have OSB. It's half-inch OSB, and then on the inside is a solid 2x4 core. So that makes it have 1.5 inches plus 2.5 inches, 2.5 inches of wood. And this one, they went ahead and were able to engage it in full power and full speed. The blade actually acted as a wood chipper, so it did remove a lot of wood. There's a lot of chips on the floor, but the furthest penetration into the wood was really only 1/2 inch. It barely got through the first layer of OSB and did not hardly penetrate into the 2x4 core. All right, for the next set of tests, first off, you notice the foam has been removed. There were some other BattleBots that were able to move if the foam wasn't there. The profile was low enough they were getting caught. And so what this test is on a composite of the wood paneling that we tested before, along with the steel plate on top. Again, it did penetrate through the steel into the wood, but it did not manage to go even through the 1/2 inch OSB that's behind the steel. The importance of this test is that the blade does not penetrate outside the cage area at any point, even when it penetrates through the steel with a direct hit. All right, finally we have Battlebots um, fight. There's two robots here. One of them, the Darth Maul, is the one that's swinging the red blade, and the other one is an omnidirectional uh, steering robot. What's happening here is with the cameras, it's switching between a front and back projection. So you notice we're at the back of the cage, and now we're looking at the front of the cage. The omnidirectional robot struggled when it got caught on the foam. So you can see we're at the back of the cage here. Both robots sustained some damage. The Darth Maul robot had some damage to the belt and weapons pulley, so there was some contact, but it also lost a sprocket, which we'll see at the end, or drive wheel, which we'll see at the end. But the omnidirectional robot, the biggest problem was that it got caught on the foam and wasn't able to move around. So there's a good hit. At this point, the protective cover has been shattered, so it's just a matter of time here. Switching to the front, they are caught on the front of the cage, and so now Darth Maul weapon has a chance to get to full speed. Notice their drive wheel on the right side is not able to move, so they're trying to get in position to get a hit. And also, if you notice the top cage, there wasn't much holding it until that final blow. So overall, the teams did a great job building robots. These are really powerful robots. Here's some of the damage. There's the belt on spinning blade and some frame damage. And then obviously some frame damage on the other one as well. And fully destroyed robot. The cage also held up to what we were expecting it to in terms of containing the blasts. So this ends our first year of the cage design. Hopefully with next year we can add some things, ceiling and thicker panels on the walls, and better testing, better control of the gaps, and some other things that we want to improve.